Here we have an exponential equation, and in this exponential equation we have to solve for x. That is, we have to find the value of x. Okay, whenever I'm trying to solve for a variable that is at exponent, what I need to do is I have to get the same base on both sides of the equation. Once I get the same base on both sides of the equation, I can equate the exponents and I can solve for the variable. Okay, here on the left side we have the base 27 over 8, and the right side we have base 2 over 3. I know that 8 is a power of 2, that is 8 can be written as 2 cube, and 27 is a power of 3 and it can be written as 3 cube. But we need the 2 in numerator and 3 in denominator. So according to the base we have on the right side. Okay, here on the left side the exponent is negative, that is negative 3x. So if I change this negative exponent as positive, what I need to do is I have to take reciprocal for the base, that is 27 over 8. Okay, so now first in my first step what I'm going to do is I'm going to change the negative exponent, that is negative 3x, to positive exponent, that is positive 3x. So if I change the sign negative as positive, it will become 3x. Then what I need to do is I have to take reciprocal for the base. So when I take reciprocal for 27 over 8, I'm getting 8 over 27. So I'm writing the stuff on the right side as it is. That is 2 over 3 whole to the power of x positive 16. Okay, so now already I know that 8 is a power of 2. So 8 can be written as 2 cube, and 27 can be written as 3 cube whole to the power 3x equals to 2 over 3 whole to the power x positive 16. Okay, in my next step what I'm going to do is here for the numerator here we have exponent 3. In denominator also we have exponent 3. So in a fraction we have the same exponent for numerator and denominator, and we can write the exponent in common. So that is 2 over 3 whole cube. That is, I am writing this exponent in common for both numerator and denominator. Already we have the exponent 3x. Okay, we can write that exponent too. So equals to 2 over 3 whole to the power x positive 16. Okay, so here let's consider the power of a power rule in exponent. What is the power of a power rule in exponent? So let's consider the base a and exponent m, and for the whole stuff let's consider the exponent n. So whenever we have two exponents like this, what we can do is we can multiply these two exponents, that is m times n. So I'm just going to use the power of our power rule we discussed over here. So in our equation on the left side, so here the base is 2 over 3 and we have exponent 3, and for the complete stuff we have the exponent 3x. So what can we do with the two exponents over here? We can multiply them. So I'm getting 2 over 3 whole to the power, so 3 times 3x, that is I multiply these two exponents. So whatever stuff I have on the right side, I'm writing it as it is, that is 2 over 3 whole to the power x positive 16. Okay, so in my next step, 2 over 3 whole to the power. So 3 times 3x is 9x equals to 2 over 3 whole to the power x positive 16. So now I have the same base on both sides of the equation. So here the base on the left side is 2 over 3 and the right side also the base is 2 over 3. So whenever two terms are equal with the same base, what we can do is we can equate the exponents. So there is 9x equals to x positive 16. Okay, now we have to solve for x in this equation. For that, I subtract x from both sides. When I do so, the positive x, negative x will cancel out. 9x, negative x on the left side, I'm getting 8x. On the right side, we have 16. So to solve for x, I divide both sides by 8. When I do so, this 8 will cancel out. I'm getting x equals to, when I divide 16 by 8, I'm getting 2. So I have solved for x. The value of x in the given equation is 2.